Welcome to today's Explainer. We're tackling a massive, incredibly frustrating bottleneck that plagues both human developers and AI agents alike. Today, we're unpacking a powerful open-source tool called Crabbox. If you've ever felt the absolute friction of remote testing just killing your momentum, you are in exactly the right place. Okay, let's dive right in by addressing a pain point literally all of us know entirely too well: the endless, mind-numbing cycle of committing a dirty work-in-progress branch purely because you need to test it on a remote runner. It breaks your flow, it's exhausting, and let's be honest, we all have those embarrassing git commit histories with 10 consecutive messages that just say, fix test, fix typo, or simply, please work. The contrast between the two approaches is honestly night and day. On one side, you've got the traditional agonizing loop. You push, you wait for the continuous integration pipeline to trigger, you squint at logs through a web browser, and then you rinse and repeat. But on the other side, we have the Crabbox way, which delivers instant gratification with just one elegant command. Here is our roadmap for today. We'll start with the CI waiting game, introduce Crabbox, peek under the hood at its architecture, explore your compute options, dive into the OpenClaw AI connection, and finally get you set up to start using it. Section 1, the CI waiting game, and the real problem with traditional pipelines. The Crabbox documentation perfectly captures this universal developer frustration. Seriously, we've all been there, right? You find out a test only fails remotely because of some bizarre environmental quirk. So you make a tiny tweak, commit with a message like, fix test again, and you wait another 10 minutes. It is a massive, massive drain on your productivity. Which brings us to Section 2. Enter Crabbox, the one-command solution. So the crucial takeaway here is this single, powerful command, Crabbox run. You follow that with whatever test command you want to execute, like, say, pm test. Behind the scenes, Crabbox handles the entire remote execution sequence. There's no git push. That's the real magic here. No git push, no waiting for a webhook to fire, no context switching to a browser tab. It feels exactly like you're just running it locally on your machine. This whole elegant solution breaks down into a really clean 4-step lifecycle. First, Crabbox automatically leases a fast remote managed compute instance. Second, it uses rsync to copy your current local checkout. And this is key. It includes your uncommitted, dirty changes. Third, it runs your command and streams the output directly back to your terminal in real time. And finally, the second the command finishes, it instantly releases the lease. The whole cycle just happens seamlessly in the background. Moving on to Section 3, under the hood. Let's peel back the curtain and look at the 3-piece architecture powering Crabbox. The very first piece is the Go CLI, running right there on your machine. This lightweight binary is basically the mastermind of the operation. It loads your config, mints a brand new per-lease SSH key for maximum security, asks for a lease, and handles that local workspace sync. And because it relies on rsync, it tracks exactly what is physically on your disk. Well, tracked in non-ignored files anyway, not just what you've formally committed to Git, meaning what you see locally is exactly what gets executed remotely. The second piece is the Cloudflare worker broker, typically hosted over at Crabbox OpenClaw.ai. This is brilliant because it ensures your laptop never actually has to hold the raw cloud API keys for your infrastructure. The broker uses a durable object to serialize the lease state, enforce monthly spend caps, and this is a lifesaver, automatically expire stale leases. So you don't accidentally run up some massive wallet-draining cloud bill just because you closed your laptop for the weekend. And the final piece of the puzzle is the runner itself. This is the actual physical or virtual environment where your code gets executed. It's provisioned on the fly, prepared with a baseline of prerequisites like SSH, Git, and rsync, and once your test is done, it's completely wiped out. You get a pristine, clean room environment for every single run. No lingering state, no weird leftover files. Let's jump to Section 4, Choose Your Compute, which offers some truly unmatched flexibility. Because Crabbox absolutely does not lock you into one ecosystem. It actually supports over 20 different computing providers. Need to test an iOS build? No problem. It can spin up an AWS EC2 Mac instance. Need cheap, lightning-fast Linux testing? Hit up Hetzner Cloud. Prefer to test locally? It integrates perfectly with Docker Desktop and OrbStack. It even delegates to specialized AI agent sandboxes like Modal, E2B, Upstashbox, and TensorLake. The sheer flexibility here is, frankly, unmatched. You basically have two primary deployment options to choose from. You can use brokered mode, which is absolutely perfect for teams. In this mode, the provider credentials stay securely locked in the Cloudflare worker, which lets maintainers and AI agents share infrastructure without ever passing around sensitive provider tokens. But alternatively, if you just want a private local test lane for yourself, you can use direct mode. That bypasses the broker entirely and just uses your own local cloud credentials. Section 5, the OpenClaw connection. Let's look at building the future of autonomous agents. So let's shift our perspective for a minute from human developers to the future of software engineering. While a solo developer uses Crabbox to save their laptop's battery and iterate faster, an OpenClaw agent uses Crabbox for something even more profound. You see, OpenClaw skills are way more useful when they can act on real infrastructure. Crabbox slots right in seamlessly as the agent's physical execution layer. The AI can write a patch, instantly invoke Crabbox run to test it on a real cloud VM, gather the output logs and telemetry as evidence, and report back completely autonomously. And what's truly fascinating is just how deep this integration actually goes. The Crabbox repository root is actually a native OpenClaw plugin itself. Inside the repo, there's an agent skills directory that contains first-class skill definitions. What this means for you is that if you're running an OpenClaw agent, it can natively use Crabbox to warm up boxes, sync code, run heavy test suites, and inspect run history, all without you having to write a single line of custom integration code. It is literally agent-ready right out of the box. Finally, Section 6, getting started. Let's cut that loop today. Getting set up is an absolute breeze. If you are on macOS or Linux, you can install the Go binary using Homebrew, or just grab an archive straight from their GitHub releases page. Next up, you authenticate via GitHub OAuth using the Crabbox login command. And finally, you run the built-in Crabbox doctor command. This is a brilliant little feature that checks your local prerequisites, making sure you have tools like rsync and SSH installed, and it verifies the broker is reachable before you ever attempt your first run. It really couldn't be any easier. Whether you're a solo maintainer tired of watching your local machine freeze up during heavy test suites, or you're building the next generation of OpenClaw AI agents that desperately need real-world hardware validation, Crabbox completely eliminates the CI waiting game, leaving us with one final question to ponder. Are you going to keep pushing dirty branches and staring blankly at loading spinners, or are you ready to cut the loop and transform your entire workflow today?